I'm Loris, and today I'm just going to present a very interesting topic called fractals. So let's get started. Let's take a look at these kind of pictures at first. So this is a Romanesco broccoli. It looks pretty weird. Actually, I've never seen it in my real life. And this is a seashell. This is a Cook Snowflake, and this is a fern. This is the galaxy. So what do these pictures look in common? So the answer is, actually, when you take a look at these kind of pictures, each smaller part of it is a miniature replica of the bigger one. So let's take a look at this one, this fern. It will be easy for us to look at. So each smaller fern is a miniature replica of the bigger one. So this actually brings us what is the meaning of fractal. What is a fractal? So fractal is a geometric object that is similar to itself on all scales. So you take a look at this, even this question mark, actually this is a fractal. So if you zoom it in, you will see the same pattern over and over again. But fractals actually are not perfect in our real life. Like as we just said, we just looked at those kind of pictures, and in the nature, fractals are not mathematically perfect. The main version of the fractal might be slightly different from the whole one. So, but in the pure mathematics, the fractals are mathematically infinitive. So let's look at this one. This is a pure fractal called Mandelbrot. So it basically made by repeating a mathematical formula over and over again, which is also called a recursion. So if you take a look at it, and when it zoom in, you will see basically the same thing over and over again. And similarly to the Mandelbrot side, this is the Cantor side. This is like a little bit easier to understand than the last one. So basically, there's a line, and you take a line, divide it by 2, and do the same thing over and over again to the new products until infinity. So you will get something looks like this one. And if you zoom it in, you will see the same thing over and over again, which is really cool. And right now, let's take a look at a Cook Snowflake. So you take 2 equilateral triangles and lay them on top of one another to make a star. And you do this same step over and over again. You will get something looks like a snowflake. And if you zoom it in, you'll see the same snowflake over and over again. And if you look at it for a long time, you probably will feel a little bit dizzy. That's what exactly I'm feeling right now. So we can take a look at that one for a really long time. And this is a simple mathematical formula of the Cook Snowflake. So basically, there's one line of the triangle, and then it becomes 4 lines. So it actually increases 3 lines, and one line increases 3 lines. Here it has 4 lines, so it increases 3 times 4 lines. And you do it over and over again. You will get something like this. 3 times 4, so it actually increases 3 times 4 to the power of infinity. So right now, let's take a look at some real-life applications, which is really amazing. So the fractals can be used in many other different fields. But today, I'm just gonna especially talk about the applications in wireless communications and some quantum field. So the first one is fractal antennas. I don't know if you guys ever heard about this. It looks like this. So it's different with our normal antennas. So basically, the normal antennas can only pick up one type of signals. So for example, the TV antennas can only pick up TV channels, and radio antennas can only pick up from radio stations. But fractal antennas, these fractal antennas looks like a Cook Snowflake. Because it repeats itself more and more, so the fractal antennas actually can get more and more signals, which will make our life easier. And this is designed by Nathan Cohen. And Nathan Cohen also used another fractal called Menger sponge. and this is Menger sponge. Unfortunately, I can't find any moving pictures of this kind of 3D version fractals, but just imagine that if you zoom it in, you will see the same thing over and over again, but just in 3D. So he uses this, Nathan Cohen used this Menger sponge to create a new fractal, and he used that fractal in our cell phones. So that's why our cell phones can pick up a lot of signals, much more than the TV antennas or the radio antennas. And right now, this is a really interesting part. So this is the fractals in quantum field. Before we get into that, we can take a look at this little triangle. So it's called Serpensky Triangle. So similarly, this is also a fractal. If you zoom it in, you will see the same triangle over and over again. This is amazing, but I'm a little bit dizzy by saying this. So in 2018, some scientists, they actually use a microscope, and they actually pictured this one. These are actually electrons. So they put some carbon on the copper, because copper can let the carbons move freely. So can let the electrons move freely. So actually the electrons can be in this figure, but in which dimension? So we know that the electrons will be like a line in one-dimensional, and the electrons can be like a shade in two-dimensional, and the electrons can like figures like a cube in three-dimensional. But this one is actually the electrons in 1.58 dimensions, so which is a fractal dimension. And this is really cool, because basically these fractals, if you zoom, these electrons, if you zoom it in, you will see the same thing over and over again. And the length of this triangle of this like tiny Serpensky triangle is just 20 nanometers, which is pretty small, pretty tiny little triangles, which is really cool. And like someone might want to ask, like, what can it do? So actually, this kind of electrons, they can be made to some like stretchable electrons or self-healable electrons, like this kind of real life applications. And with each stretchable electrons, it can be make some clothes or some other things. But just imagine this, probably in the future, we can really make a superpower suit by using these electrons, and we can really have a superpower in our real life, just like those kind of Marvel movies or other movies. That's all for my presentation, and thank you for all of you guys. Hopefully you guys will like that.
So thank you guys. It was the presentation of Zuhu.